Dear students, Assalamu alaikum. We are discussing Lenz-Makers formula. Today we will see how the Lenz-Makers formula for a convex lens is derived. In the previous class, we have discussed what the Lenz-Makers formula is a relation between focal length f, radii of curvature, and center of curvature. Then assumptions and the new sign convention. Today we will see the derivation. Here I have derived the equation. Here this is a lens, convex lens. It is made up of a material of absolute refractive index N2. This lens is placed in a medium of absolute refractive index N1, while N1 is greater than N2. That means the refractive index of the medium is less than the refractive index of the material of the lens. Now this lens have two spherical refracting surface. First one is XP1Y and second is XP2Y. Now there are C1 and C2. These are the centers of curvatures, and R1 and R2 are the radii of curvatures respectively. And C is the optical center of the lens. I have drawn the figure here. I will repeat it. Here is a lens of absolute refractive index N2. It is placed in a medium of refractive index N1, while N1 is less than N2. The lens is comprised of two spherical refracting surfaces XP1Y and XP2Y. C1 and C2 are the center of curvatures, and R1 and R2 are the radii of curvatures, and C is the optical center of the lens. I have written it here. Now after that, look here. Here let O be the point object. This O is the point object placed in rear medium. O is a point object placed in a rear medium on the principal axis of the refracting surface XP1Y. Look here, O is the point object lying on the principal axis of the placed in a rear medium. The refracting surface facing the object is XP1Y. Now look here, OA is the incident ray. This OA is the incident ray. After refraction at the spherical surface, post refraction XP1Y, it goes and bends towards the normal AC1. This incident ray OA after refraction at A bends towards the normal AC1 and meets the principal axis at I1. OA is the incident ray O is the incident ray after refraction at A, after refraction at A bends towards the normal AC1 and meets the principal axis at I1. Look here is I1. So what is I1? The I1 is the real image of the object O if the second surface XP2Y were not present. Principal axis and meets the principal axis at I1 if the second surface XP2Y were not present. That means if we consider that this second surface XP2Y1 is not present there, then this refracted ray this incident ray OA after refraction at A meets the principal axis I1. So what is the I1? I1, therefore I1 is the real image of the object O. Now look here, O is the object placed in the rarer medium and I1 is the image formed in the denser medium. So we have derived in the previous class sheet that the refraction through refracted surface when the object is placed in the rarer medium and the image is formed in the denser medium, we have a relation since the object O is placed in a rarer medium, we have a relation minus n1 by u plus n2 by v1 is equal to n2 minus n1 divided by r1. Mark this equation as equation first. Why this equation? Because the object lies in the rarer medium and the image is formed in the denser medium. So we have n1, but what is n1? N1 is the refractive index of the medium in which the lens is placed. U is the object distance. N2 is the refractive index of the material of the lens, and V1 is the image distance. Here V1 is the image distance is equal to N2 divided by N2 minus N1 divided by R1. R1 is the radius of curvature of the surface X P1Y. Now dear students, as we see here, this ray, refracted ray AB, after refraction at A is refracted by the second surface XP2Y. XP2Y, it is refracted here and it meets the principal axis at I and meets the principal axis at I. Look here, this I1, it acts as a virtual object for the surface XP2Y. If this I1, the point I1 acts as a virtual object placed in a dense medium or spherical surface X2Y. This point I1, it acts as a virtual object for the reflecting surface XP2Y1 placed in a denser medium. Now there is a second case, that means the object is placed in a denser medium and the image is formed in a rarer medium. Since the object is in denser medium and image is formed in rarer medium, then we have minus n2 by v plus n1 by v is equal to n1 minus n2 divided by r1. Now here, in first case, object was in the denser medium and image was in the rarer medium. Now the object is in the denser medium, image is in the rarer medium. So we have n minus n2 by v1 plus n1 by v1. n1 by v is equal to n2 divided by n1 minus n2 divided by r2. So we can write this equation or like this: minus n2 divided by v1 plus n1 by v is equal to minus n2 minus n1 divided by r2. Mark this equation as equation second. So we have obtained two equations. First, the object is in the rarer medium, image is formed in the denser medium. The equation is this, and when the object is in the denser medium, image is formed in the rarer medium, we have this equation. Now after that we will be calculating, and by adding these equations we will obtain the Lennon-Nichols formula for a convex lens. That will be continue inshallah in the next class. Thank you.